Um, so I'll be talking about machine learning demos, and as Conrad mentioned, specifically the Gradio library, which I'm one of the founders and one of the developers behind. We have a team at Hugging Face that works on this library and kind of supports it using kind of the Hugging Face ecosystem, and we work closely with the open source community on the library as well as on supporting these demos. So I'll talk about why I think machine learning demos are particularly important and why I've chosen to work on that for the past few years. And then the majority of this talk will actually be a pretty hands-on tutorial using Gradio. So if you use Gradio before, we'll dive into some kind of features that maybe you haven't used before. And if you haven't used it before, that's completely fine as well because we're starting from the beginning anyways. So, all right, let's jump into it. So first of all, I really think that we're actually at a historic moment in the usage of machine learning. It used to be like just a decade ago. And my background, by the way, is in academia. So before starting Gradio, I was doing my PhD at Stanford in machine learning. And even just, less than a decade ago, machine learning models were primarily used by other machine learning engineers. The idea that you would train a machine learning model and it would become widely used by ordinary people on their browser or something like that was not common at all. So it's mostly used by other machine learning engineers. And then you had the rise of libraries like transformers and kind of other high-level abstractions that made machine learning models easier to use, particularly if you were a software engineer. Okay, so first you had like machine learning engineers, and maybe you had broader software engineers. And then now we're at a point where a machine learning model, it'll go viral on social media, for example, because anyone can use it. Anyone can use it through a GUI. So we've seen many examples of many examples of that. Things like Dolly Mini, Stable Diffusion, ChatGPT. All of these models, all of these machine learning models go viral because they're actually used and intended to be used by all of us. Anyone really, not just machine learning specialists, but anyone who can use a GUI or a browser. In many ways, I think it parallels the rise of personal computing as well. Originally, you had the hackers, the dedicated engineers. Then you had kind of kind of broader software engineers, and now we expect everyone to be able to use a personal computer. We see something like that happening with AI as well. And so, why are machine learning demos so important? Why is this change, I think, so good for the field? I think demos are important because of three big reasons. One is accessibility. So we've already talked about that. So just increasing the number of people who can actually use machine learning. The second thing is exposing hidden biases. So this is something that it's been talked a lot about, but I think it's still very, very important. It's still very prevalent. So like, for example, this here on the right, I'm showing the output of a state-of-the-art machine learning image classifier. When you give it two sorts of images. Okay, the image on the left is an image of the bride in typical Western cultural attire. And if you feed it into a machine learning model, it'll give you the following labels. It'll tell you this is a bride, this is a dress, this is a woman, reasonable kind of labels. If you feed it an image of a bride in typical Pakistani or Indian attire, I'm from Pakistan, it'll actually say things like it's a performance or it's a costume. So we're still struggling with these questions of cultural biases present in machine learning models. And the reason they're so hard to kind of root out is because you need lots and lots of people to test out your machine learning model and give feedback on where it's working, where it's not working. And so that's where demos are particularly important because they let everyone, not just those with a technical background, try out your machine learning model. It's not always reasonable to expect a technical, the machine learning model developers to know everything about every culture and all of the biases that could be prevalent. But if you release your model in a way that many people can try it out, through these demos, you can get that feedback and improve your model's performance. And then finally, I think this is a very important one, but one that isn't talked about as much, is that demos refocus researchers on what's useful to users instead of benchmarks. Okay, so let me kind of elaborate here a little bit more. So a lot of times we've seen that machine learning, the field of machine learning in the last decade, at least maybe in the last few decades, has been very benchmark driven. So someone releases a data set and you try to build a machine learning model that scores as high as possible on that data set. Unfortunately, that's not always what users care about, right? There's this gap between real world performance and kind of benchmark performance. And in fact, there's even a gap between the kinds of tasks that researchers care about versus what users care about. And demos can help refocus researchers. I'll just give a quick example here. So this here is a very popular model, latent consistency model. In the last few weeks, it's gone super popular because it allows you to generate machine learning image. Allows you to generate images using models that are consistent thematically and stylistically. So that if you were, for example, writing a story, you could reuse these images, in different poses and so on, and different scenes. So this is a super important task, but it's not traditionally one that has like benchmarks for. Like typically when you think of image generation, you think of benchmarks such as FID score and other scores that generate how realistic the image is. That's fine, but that doesn't necessarily capture what users care about. And so releasing demos allows this feedback loop between model developers, between demo developers, and users who can communicate to kind of model developers. This is actually important to me. This is a task that's important to me. Let me try it out. Let me see how well the model's working on this task. So for all of those reasons, I think demos are very, very important. Traditionally, it's been hard to build a demo for a machine learning model. I remember when we started Gradio a few years ago, we would talk to a lot of model developers who actually really wanted to show off their model that they built with a web application. But then they found, wait, I need to learn not just web hosting, not just serving the model efficiently, Flask, Docker, web hosting, all this kind of stuff. But then I also need to learn front-end development in order to create a good model, JavaScript, CSS, HTML, of course. And so a lot of folks would be like, it's okay, I'll move on to the next project I have in mind. We'll just let this machine learning model kind of gather dust in a GitHub repo somewhere. So that's what we wanted to change. And that's why we started Gradio. So Gradio at its core lets you do all of this, like what I described, creating a machine learning demo or a performant machine learning web app in just a few lines of Python code. The core Gradio class, the one that is you got to know if you're starting out with Gradio, it's the Gradio interface class. And what the interface class does is it basically creates this GUI for you for any sort of input/output model. So in other words, let's think about a typical example. Let's say you will build a model to generate images based on a text prompt. Okay, so this is something like Stable Diffusion or the recent Playground V2 model that came out. There's a lot of models in this vein now. So what you would do with Gradio.interface is you would pass in 3 parameters. You would pass in a function. So a function is literally any Python function. Okay, so the interface kind of wraps around this function. You tell it what kind of inputs you want. So here we're saying that there's only a single input. It's a text box. And then you say what kind of outputs you want. In this case, we have a single output, which is a gallery of images. And that's it. Okay, so those are the 3 required parameters. You can also pass in more than one input. And if you pass in more than one input, like a list of input components, then those get mapped to the arguments of your of your function. So it's pretty intuitive. So if your function took in multiple parameters, it will take, as we'll see in our hands-on tutorial, you just pass in a list of inputs. And if your function returned a list of outputs, you would have a list of output components here, and they would get mapped directly. All right, so once you do that, you can do this method here, .queue, and this actually creates a very performant, very scalable queuing system for kind of that can handle many, many requests that are coming in. As of Gradio 4.0, this is optional because the queue is built into every Gradio app. So you might not see this in your kind of machine learning demos, but it's kind of there implicitly. And then finally, you do .launch. And if you want, you can do share equals true. This is not required, but let's just pretend that it's not there for a second. That's all the lines of code that you need. So what, like 5-6 lines of code in order to create a performant GUI for your application. And then you can start sharing this as well. So that's what share equals true does. So share equals true creates a public link for anyone to try out your demo. So no need to worry about web hosting, no need to do anything. You actually get a public link that maps directly to your computer that you can share with your collaborators, you can share with your colleagues, you can share with your family, and they can try out your machine learning model that you've built. So it's a very, very cool way, very low friction way for anyone to try out your machine learning model. Okay, so we released Gradio a few years ago, and we're very fortunate to see it has taken off in the last couple of years. At this point, we have more than 500,000 unique monthly active developers building with Gradio. They've built more than 15 million Gradio applications. And the number of users of these Gradio applications is actually much, much more. So these are just the folks that are building with Gradio, and then they share their Gradio applications with other people. And so we end up, kind of seeing Gradio used in a lot of cutting-edge machine learning workflows, but also all sorts of other things. Like recently, I was contacted by someone who built a website for their high school science fair using Gradio. We see all sorts of things from cutting edge of machine learning all the way down to things like tax calculators, to things like really any sort of time you want to build a web application, you can consider Gradio, especially if it's model intensive or data intensive. Of course, there's a lot of super popular Gradio libraries, Gradio applications that are used. You might have used them. You may have used them without knowing that you're using Gradio, but things like the Automatic 111 library, as well as its variants like FOCUS, as well as SDNext, all of these popular kind of image generation libraries are built with Gradio. And then there's also Hugging Face Spaces, which is a thing that we've built at Hugging Face. So Hugging Face is kind of a central platform for hosting machine learning models, data sets, but also these demos. And we've built Hugging Face Spaces as a place where you can actually host your machine learning demos. So once you're ready and you want to share them with other people, and you can, there's also discoverability features. There's also things like discussion features. So, people can comment and kind of discuss things based on your machine learning model or machine learning demo. And people can open pull requests against your demo as well. So it's kind of like a centralized place to kind of host your machine learning demos. And it has a very generous free tier as well. So if it's CPU based, you don't have to pay anything. Spaces will just host it for free. And if there's GPU based demos, you do pay a little bit based on the uptime, but stay tuned. There's going to be some exciting developments for that soon. And it's super easy to set up a space. If we have time, we might end up doing that as well as part of this interactive tutorial. Okay, so with that, what I'm going to do is I'm going to change gears a little bit, and we are going to actually dive into writing code. And so what I've done is I've prepared this nice collaborative tutorial here. So it's a Colab notebook that you can use to actually run a lot of this Gradio code. And it's designed specifically for, if you're starting Gradio from scratch, but we'll also cover some advanced features. So it'll give kind of a nice introduction to the kind of the Gradio ecosystem. So I'll come back to this slide here real quickly. So if you'd like to follow along, you can actually type this URL into your browser. It's https short url.at. So short url.at/ and this is important. This all has to be uppercase DJTU2. So I'll give maybe just a few seconds for everyone to open this up in their browser.
We've also just added it to the chat window, the URL.
Oh, perfect. Thank you. All right. So it's in the chat window. I'm hoping everyone has a chance to open it up now. And if you do, it should open up this Colab notebook for you. And I'm just going to make sure that everyone has permissions. Yeah, everyone should have permissions to open this. Okay. All right. So we're going to start off with installing Gradio. So you just go ahead and kind of skip over this introductory material since we've already kind of talked about this, and go to this first slide, first code block rather. And if you haven't used Colab notebooks before, it's just interleaved code and text, and you can run any cell by just doing Control Enter. So if I go ahead and do Control Enter, this or Command Enter if you're on a Mac, it'll go ahead and run this. And you can see it's installing Gradio right now. And it might ask you kind of, do you trust this notebook? You can say yes. And then it'll go ahead and install Gradio. So it's super easy to install Gradio. All you do is pip install Gradio. It's just a Python package. Even though it does a lot of front-endy stuff as well, at the end of the day, it's just a Python package. So you can just pip install it. You might get these warnings. It's completely fine. You could ignore it for now. Okay, and then we'll get started. So we're going to start off with Gradio's interface class. So the reason we're going to start off with the interface class is it lets you build demos very, very fast. Now, after this, we'll actually talk about what to do if you want more flexibility and customization. But for now, we'll start with this interface class. Okay, so first of all, go ahead and start by importing Gradio. Then we're going to define a function. Okay, now this function is going to be an image. It's going to mock an image classifier function. Okay, so the function is called classify image. It takes in an image, and right now all it does is just return this fixed set of probabilities. Okay, of course, typically this would come from your machine learning model, but we'll get to that later. Right now, I just want to kind of convey how Gradio works, because Gradio can wrap around any Python function. So whether it's a machine learning model happening inside of this function, or whether it's something else, it doesn't really matter. So okay, so then now we actually write this, really just one line of Python. It's just formatted for multiple lines, but it's really just one line of Python. It's a gradio.interface. Okay. It takes in a function called classify image, which is this function we defined above. And for the input, we're going to want an image component. Okay, so we've specified this right now as a string. You can do it as a string, or you can do it as the gr.image class. We'll talk about what the difference is in just a second. But for convenience, you can just specify it as a string. And for the output, we want a label. Okay, so I'm actually just going to jump to the Gradio docs for a second, because I think it's important to understand what's going on here a little bit. If you go to the docs, you'll see that Gradio comes in with more than 30 different components. So these components they're designed for common machine learning workflows. So we know a lot of people work with audio, for example. We know a lot of people work with chatbots. A lot of people work with code. A lot of people work with annotated images. And so these are kind of the common common components that we've built in to the workflow. So the two that we're going to be using right now are image. So image is, let's see here, image is here, and label is here. So image and label. So again, I can either specify them using the string here, or I can do gr.image. But for now, we're just going to specify using the string. And you can see, and then I just do .launch. That's it. And now I have a GUI that just got launched inside of my Gradio, inside of my Colab notebook. So if you run this cell, you'll see the same thing pop up for you as well. And so now I can drag and drop images into here. So let me go ahead and drag and drop the cheetah image. And you can see here, now I have my, my machine learning model, my mock machine learning model running in the background. I get my predictions back, and now it's showed in this kind of nice UI here. All right.
Oh, so sorry, you're still on the Gradio documentation.
Oh, sorry. Yeah, thank you. Yeah, thanks for that. Yeah, so now we're back at the Colab notebook. So I ran this cell. I ran this, this cell here. I'll actually just do that again, just for kind of visibility. So this will launch this Gradio application here. I'll go ahead and I'll drop this. And I have an image here that I've uploaded. You can also take an image from your webcam or paste one from your clipboard by clicking on this. But we just uploaded one here. And I've run it. And now I get my predictions from my fake machine learning model. And I have this nice UI that explains it, that does all of that for me. Okay. All right. So hopefully that makes sense. I'm going to talk about kind of the key takeaways here. You need 3 ingredients for your Gradio interface. You need a function. You need an input component or components. We'll see that in a moment. And you need an output component or components. So you can either use the string shortcut, or you can use the component object itself. So when you use the component object, it's nice because you actually get the flexibility to customize that component. So for example, now I can do the same thing, but instead of image, I use gr.image, and I pass in a label. Okay, and in this case is going to be animal image. Okay, I can also pass in an output. So for my label component, I can say only show the top 3 classes. That's all we should show. Okay, so I'll do that again. So now you can see I have a little label here. This is animal image. And again, if I drop in the same image, my prediction now only shows the top 3 classes. So this can be useful if, for example, you're doing something like, you're working with ImageNet with 1,000 classes. You probably don't want to show all 1,000 logits or 1,000 predictions, probabilities. You probably just want to show the top 3 or top 5 or whatever it may be, and you can customize that. Okay. So that's the GR interface class. Those are the requirements. There's also some additional parameters you can put in. So for example, you can put in a title, which adds a title to the top of the UI. You can add a description, which adds a description underneath the title, and you can add Markdown or HTML here as well. I won't go into that right now, or maybe we can just run this just to see what that looks like. So you can kind of see here, there's a title here, there's a short description. There's also an article parameter that lets you put information underneath your demo as well. So it basically allows you to customize your demo very easily. So the other kind of thing that's very important is example inputs. And this is something that we've seen kind of is a game changer when it comes to letting people try out your demos very easily. So it's best to just maybe give this with an example here. So this is a little bit of a slightly more complex Gradio demo. It's a calculator. Okay, so you put in a number here, you put in an operation, you put in another number, and you submit this, and you get kind of an output here. Now, what's interesting here is that we still have a single. So we have a function called calculator. Now it takes in 3 inputs, right? 3 parameters. So what we do is we specify a component for each of those inputs. So first of all, we have a gr.number. So number is another component. And we want to give it a default value. So that's why we use the component itself. And that maps to the first parameter. Then we pass in a radio button. So we have a radio button here. And that passes to the second parameter, which is operation. And we can see like if operation is add or subtract or multiply, divide, we do different things. So we pass in a Gradio radio component. And again, now we have to use the class because we want to give it specific choices to use. And then finally, we have another number component, which maps to the last parameter here. In this case, we just use the string shortcut. I mean, just for fun, there's no real reason. We could have used gr.number as well, but just to kind of change things up. And then the output here is always a number, so we also use a gr.number. But the cool thing here is we pass in examples. So examples show up as this table at the bottom. And what they do is they allow anyone to easily, like imagine you had maybe you had an image classifier. You don't want necessarily people to have to find an image on their computer to try out your demo. You maybe want to provide a few images they can just click on immediately to kind of load the image. And so this lets you kind of do that very easily. And so you pass in examples, which is a list of lists, and each of these examples and this kind of inner list corresponds to one of the input parameters. And so by clicking on that list, you go ahead and you kind of run this, and you kind of see this. It does this as well. And the other reason examples can be very powerful actually, is because you can cache them. So if I type in cache examples equals true, what it'll do actually on launch, let me go ahead and do this right now. So you can see it's caching the example. So what it's actually doing is running each of these examples through my Gradio demo and kind of saving the results. So if I click here, and by the way, you can open this up on a new tab for easier, just to make it a little bit easier to parse. So now if I click on one of these examples, you'll see the results automatically get populated in the output. So I don't have to run them through my Gradio. I don't have to click the submit button. This can be very powerful, especially if your machine learning model takes a while to run and you want to provide this nice experience to users where they just click on an image and immediately see the output. So yeah, this is very commonly used. Okay. By the way, are there any questions? Is there a way that people can ask questions through the chat?
There is a way. There is currently one question if you would like to address it now, or you could also do it at the end of the keynote.
Cool. So yeah, I'm happy to take questions now before we jump into kind of the next topic. Oh, cool. Perfect. So there's a question here from Sebastian. I miss real-time processing in my conversational voice without turn-based buttons. Okay, yeah, absolutely. No, so Gradio does support real-time voice interactions. So the way it works is we have support for streaming audio. And what I'm going to do is I'm going to show you a demo that Kokui, which is a very cool organization, built. Let me see if I can find it. Kokui speech let me see, chatbot. Okay, cool. Yeah. So this is actually a demo that was built by Kokui. And if you haven't heard of Kokui before, they're basically a open source library specifically for text generation. So they've released a variety of really good text generation models that are all open source. And so this is cool. So they built this Gradio demo. And by the way, yeah, their library is also super popular, more than 24,000 stars and all of that. But what you can do is, this is very cool. This is a chatbot. So this is actually very similar to what you're describing, Sebastian. You can actually record from the microphone here. So you can say, hi there. What is the capital of Egypt? Okay, so let's see here. Okay, so here you kind of stop here. So this is not real time. Oh, okay. So you can see it, but it captured my...
Cairo is the capital of Egypt.
Cool. I don't know if that audio got piped through, but so what happened was, basically I recorded, it got sent here, and then the chatbot kind of processed it, and then we used XTTS, the Kokui text speech generation model, and it kind of responded with the text, and it spoke the answer as well. So this is actually possible. So actually this is not streaming, so my bad. This is kind of recording, and then you kind of submit it. But Gradio does support streaming as well. So it'd actually be really cool to actually build something like this that's streaming. If you're interested, it's a little bit beyond the scope of this tutorial, but you can search Gradio streaming audio input. And we have here, for example, we have a guide here on real-time speech recognition. So it shows how to use it with a speech recognition model from transformers, including streaming. So what you could do is basically it's not too complicated. All you have to do is set streaming equals true in the audio component, and you set live equals true in interface. And so that allows you to kind of do this kind of streaming work, and you can build a streaming model. And then what you could do is you could look for certain stop words or certain gaps for a little while. And if the input text hasn't changed, then you can kind of consider this as a processed request, and then you can do whatever you want. It would be really cool to build a chatbot kind of like this Kokui one, but entirely based, and no turn-based at all, just based on kind of talking to the chatbot. So if you do end up building that, would be very, very cool to kind of I'd be happy to try it out, maybe spread the word. So cool. Thanks for that question, Sebastian. Are there any other questions before we jump forward? Okay, so there's a question here from Ade. Okay, how does Gradio? Oh yeah. Okay, so great question. So yeah, so Gradio and Streamlit. Streamlit is also a fantastic library. Streamlit, from kind of, and they both have their different strengths. Streamlit is a little bit different. I think a lot of it is kind of designed for data processing, things like charts and kind of dashboards. Although you can also use Gradio for that. Streamlit can be used for machine learning demos as well. But there are a lot of things. So basically, kind of the fundamental difference, I would say, is that Gradio is optimized for building machine learning demos. So what that means is, for example, Gradio comes in with a lot of these components that are super relevant and super optimized for machine learning demos. Things like the annotated image component, things other things as well. It also comes in with this queue that helps you understand, especially when a lot of people are using your machine learning model. It scales very, very nicely. It tells users exactly when they should expect to get their results back, and so on. Every Gradio app can also be used as an API. So I'll talk about that in just a second, which is not the case for Streamlit apps. So there's kind of different use cases, slightly different use cases. They're optimized for slightly different things. But I would suggest trying them both out. The other cool thing about Gradio is it uses the native Python kind of runtime and interpreter, which means you can use Gradio everywhere. You can use it in a Colab notebook. You can use it in a Kaggle notebook. You can use Gradio wherever you already write Python. So yeah, it's kind of a nice thing. Perfect. Cool. Are there any other questions?
I think we should be good.
Okay, yeah. Let's go back to the tutorial then. Okay, so a couple of cool other things that you can do with the Gradio. One of them is custom theming. Okay, so we can take the same Gradio interface that we built before, but we can pass in a theme. Okay. And I'm going to pass in this theme here. I'll explain what this means in just a second. But this is a theme here right now, gstaff/xkcd. So if I pass in this theme here, you you can see the same Gradio application now looks kind of like it was drawn by the XKCD author, right? So you have like all of the font that's different, colors are a little bit different. You can use this to customize your Gradio application quite a bit. So there's another one here called John Smith 9982/small and pretty. So we'll pass that one instead. So if I pass that one instead, now you can see the Gradio application looks a little bit different. Again, functionally it's the same thing, but it just looks a little bit different. Now this is another theme that we built called Seafoam. Again, it's a little bit different. But again, functionally it's exactly the same thing. You can get very, very creative with these themes. If you are interested, we actually built a theme gallery to let people discover these themes very easily. So I'm going to go ahead and show kind of that. So this is the Gradio theme gallery. And so this actually has a bunch of popular themes that have been built by the community. So this is the XKCD theme. It was built by a user called gstaff on Hugging Face, and then they published it as the XKCD theme. And so you can kind of see when you click on this, you get to see their theme a little bit more. You get to see how different components would look like in this theme and so on. So you can try out other people's themes. You can also build your own theme. I lost that for a second. I'm gonna share my screen again. You can also build your own themes. And if you're interested, you can read the theming guide here. Okay. And then we have an interactive theme builder that lets you build and publish themes very easily. So if you're interested in that, you can just do import Gradio as gr.themes.builder. So maybe I'll just run that in case anyone wants to see what that looks like. So it itself is a Gradio app, which is kind of nice. So it'll run just fine. And you can see here, like this is a theme builder. So you can set things like you can set the kind of the base theme, and then you can kind of, change the colors. So I want the colors to be orange, maybe, do various things. And then once you're done with it, you can actually view the code for your theme, or you can actually publish the theme to the Hugging Face Hub, and you can give it a name and things like that. So, okay. So I'll take just a quick break again in case there are questions, because we're going to change gears quite a bit after this, and we're going to talk about blocks. So are there any questions about anything that we've talked about so far with Gradio, specifically with Gradio interface? Okay, looks like everyone is good. We're clear. So we're going to change gears, and we're going to talk about Gradio blocks. Okay, so why are we talking about blocks here? So the interface API is very convenient. It lets you get started very quickly. But there's oftentimes things that you want to do that you cannot, like it's just not possible to do with interface. Some levels of customization you may want. And I'm not talking about custom themes here. I'm talking about custom, you want to change, you want to group together multiple related demos, or you want to change the layout of your demo completely, instead of having all of the inputs on the left and the outputs on the right. Or you want to have a multi-step demo. You have the input of one thing becomes the output of the next, and the output of the next becomes the input of the next. You want to be able to do certain things, or you want to be able to hide certain things, show certain things. You want to build a much more complex demo, and that's where the Gradio blocks API, kind of API, or the Gradio blocks interface, the Gradio blocks class becomes very, very useful. It is basically a low-level API. So interface is a high-level API. Blocks is a low-level API that gives you complete control over how things are processed in your Gradio application, how events are processed, how things are laid out, and so on. So let's take a look at a quick example here. So I have a Gradio demo here. I'm going to run it first. So if I run it, you'll see initially it looks very, very similar to the demo I had before. Okay. And again, I pass in an image, and it kind of makes a prediction, and it's just kind of running through this fake model. It's the same thing as before. So why am I kind of, so what's the point of this? I'm just going to show you how you would build this with blocks. And initially it's going to seem like a lot more work, but we'll see why it becomes very, very useful, because it gives you complete control over how every single thing is laid out. So let's go through an example here. So first of all, we have our function. So this is just like it was before. Okay. Then this is the key line that you have to do with blocks. So you start a with statement. Okay, so you say with Gradio, with Gradio blocks as demo. All right, so with gr.blocks as demo. Okay, now everything that happens inside of that with statement gets fed, becomes part of your machine learning demo. Okay, so we'll start off by writing some markdown. So gr.markdown is a Gradio markdown component. You can pass in whatever you want. So here we pass in a string here, dog versus cat classifier, upload an image to detect if it's a dog or a cat, and we use this heading thing for markdown, and you can see it pops up right here. Okay, dog versus, all of this stuff. Then we start a row. So in a row, everything is laid out horizontally. Okay, then I don't think we have to do all of this. There's some extra stuff here that's not strictly necessary. I'm just gonna, okay, I see what's happening here. Okay, so I think we don't need, I see what's happening. Okay, we'll just leave this as it is for now. Okay, so basically what's happening, there's a few layouts here. And this is a little bit confusing. So you know what I'm gonna do? I'm gonna just change this up a little bit. I'm gonna just remove this, and I will put this here. Okay. And I'll explain what I'm doing in just a second. Okay. So what I did was I created 2 rows. Okay, so that's all in my demo. In my blocks, I created 2 rows. So the first row has an image and a label. So you can see here it has an image and a label. All right, so I drop in an image, works like that. And then if I want to, I have an image component and I have a label component. My second row has a clear button, has a button whose value is clear, and another button whose value is classify. And it's a primary button, meaning that it's going to appear like with this gold or with this orange hue, whereas by default it appears with a silverish or grayish hue. So you can kind of see that here. I have a clear button and have a classify button. So these 4 lines or so, these 5 these handful of lines, they define the layout of my Gradio blocks. So it's pretty intuitive. Things are laid out in a column format by default, unless you put things inside of a row in which they are laid out as in a row or in a horizontal kind of way. So this lets you kind of control the layout to your heart's desire. You can also do things like put things inside accordions. So if you want to put things inside an accordion, you can do something like this. So if I do this, now I have an accordion here. This accordion holds the buttons. I can collapse it, I can open it, do things like that. And then finally, the last thing that's important is you have to define your own events. So events, the way the blocks does events is super powerful because it lets you define an event for almost any sort of interaction you can imagine for any component. So here what we have is we're having it say that, hey, if I upload an image here, okay, if I upload an image, and then if I click the classify button, this one, the classify button, it should run the classify image component. And it should take as input my image component. So it should take whatever the value of my image component is as input, and it should feed it to the label component as output. Okay, so that's exactly what happens. So I run this, I click the classify button, it takes as input what is here, and it feeds as output to the label component. Now, what's cool is I can change this. I can say instead of happening when the button is clicked, I can get rid of this button altogether. And I'm gonna just simplify this Gradio demo a lot more. I'm gonna get rid of all of the buttons, and I'm gonna say, and now you can see, it's showing this error because button is not defined here. And I'm gonna say, hey, if input gets changed. So anytime input, it does not change singular. Yeah, so input.change, run this function. So what does that mean? That means that anytime the value of this input component gets changed, it should run the function. So if I upload an image, it'll run the function. So I don't need any buttons at all. I have a completely live, interactive, Gradio demo here. So you can attach any sort of events to any sort of triggers. So that's one of the powerful things about blocks. So this is kind of a quick introduction to blocks. So are there any questions here? Okay, Cool. We have a question that's a little bit okay. So it's about why we chose Svelte for Gradio. Yeah, so it's a good question. So Svelte is actually honestly a fantastic front end library. So if anyone has used kind of React before or done kind of front end work, I would suggest checking out Svelte. We used it for two big reasons. They both involve speed. First is the speed of the Gradio app itself. So Svelte is compiled. So unlike React, it doesn't kind of, you don't actually have build this kind of front end kind of reactive thing where it manages kind of the reactive state and things like that. It's a compiled language. So you write Svelte code in this reactive style, but then it gets compiled into vanilla JavaScript, which means it's extremely fast. Okay, it's extremely fast. And so one of the reasons we switched from React to Svelte, so initially we were on React in Gradio 2.x, we switched on Gradio 3.x to Svelte. And the reason was because of speed. And the other reason actually was speed of developer, kind of the learning curve. So again, we have a team of both front end and back end folks, and sometimes the Gradio team, like for example myself, I'm much better at back end than front end, but I've learned Svelte very, very quickly because it's very intuitive. It's built on top of kind of regular JavaScript with some additional kind of modifiers and additional syntax. So if you know vanilla JavaScript, learning Svelte is super fast and it's very intuitive. It's just a beautifully designed language. Whereas it took me much, much longer to wrap my head around React, and kind of, for the new folks who've joined the Gradio team as well, we've had new hires since, we've got acquired, for example. They've all loved Svelte. They've all gone up to speed very, very quickly. So I would say like the speed of kind of the developer learning curve, as well as the speed of the actual kind of runtime of the Gradio application. So great question by Simon, actually. So how far would you say that you can push Gradio for use cases that exceed the demo phase? Actually, quite a bit. And I'm going to talk about that in just a little bit. So let me come back to that. I'm going to talk about using Gradio as an API. So actually, I'll just quickly mention it now, and then we can come back to it in a little bit. So one of the cool things whenever you build a Gradio application is you get an API for free. So like I said, let's take a look at this one here. This is the funky Gradio application that I built here. You'll see at the bottom, it says use via API. And so in addition to the core Gradio library, we've also published two Gradio client libraries, one in Python, one in JavaScript or TypeScript. And these let you use these Gradio applications very, very easily. So for example here, so here I have this Gradio application running on this URL here. So if you wanted, you could actually start querying it immediately right now using the Gradio client. You could, if you were to install this and run this, it would literally run a query against this application and you'd get a prediction back. Okay. So I won't do that right now. I'll do that maybe in a little bit. But the point here is actually you can actually build a Gradio application, and then you can actually kind of launch it, and you can keep it running, and you can use it programmatically as an API. And it works quite well. We have a queue that scales to thousands of requests. It's very performant. We've actually switched from using WebSockets to SSE, which has a bunch of nice advantages as well. It runs in much more environments. So we've actually seen people take Gradio applications quite far. Very, very popular ones. So for example, you may have seen like the illusion diffusion space. Let me actually see if I can pull it up. Illusion diffusion. So this is a Gradio demo that was built by a community member, AP123. It's very cool. You upload an image, and then you kind of you upload a pattern, and then you can describe something that you want, and it generates a pattern with that particular illusion baked into it. It was kind of viral on social media a while back. But it has, it's super popular, almost 3,000 likes here, used very, very frequently. And there's a queuing system that kind of manages everything, requests coming in, and allows it to scale kind of very, very high. So yeah, you can use it for production use cases, really. And if there's, and actually we've been thinking about this a lot more recently, being able to provide more visibility and analytics to people who are using it in these kind of production use cases. So if that's something you're interested in, please let us know. You can reach out to us on Twitter or through the GitHub repo, and we're happy to kind of help you get set up for production use cases. And of course, it's like everything is open source, so everything is free. Okay. Cool. I think those are. Oh, okay. So there is one more question here by Callian. How much computing time is required to build a domain-specific application in real time in Gradio? That's super kind of specific to your machine learning model. It's hard to speak generally. So Gradio, you should think of it as kind of a wrapper over your machine learning model. So it doesn't add any sort of computing power. So whatever you would need to normally run it is still the case. And Gradio can manage how many people, for example, can concurrently use your machine learning model at the same time. So if you want it to be limited to just one person using the machine learning model, that's completely fine. If you want multiple people to be able to use it because you support that for the computing power, you can also set that as well. And actually, this goes back to the production use case as well. I won't talk about this for just because it's a little bit beyond the scope of this talk, but you have fine-grained control over how many people can run your machine learning model at the same time as well. This is something that we released in Gradio 4.0, so this is somewhat new, but cool. Okay, so we just have about 10 minutes left. So the last thing that I'm going to talk about, well, let's see here. Yeah, I think maybe I'll talk about this here because we've had a lot of questions about real time and iterative output. So so sometimes machine learning models, they stream data back to the client. So you can think of a chatbot that's streaming data back. You can think of an image generation model that kind of is a multi-step image generation model, and you want to show the intermediate steps to the users. The cool thing is Gradio supports that, and in a very Python native way. So in your function, instead of returning a value, you can yield a sequence of values. And if you yield a sequence of values, they show up in an iterative way back to the front end. That's it. That's all you have to do. There's literally no other changes to your Gradio application. So here, what I'm going to do, for example, is I'm going to count to 3. And so you can see here, it's kind of, let me actually just increase that. Maybe count to 6 or something. Let's do count to 6. Okay, so you can see here 0, 1, 2, 3, 4, 5. It's just counting back, and the way it's working, it's just I have an input that gets fed into this, count to n, and then it just runs a for loop until n, and it yields that value and it sleeps. Now, obviously, this is just a fake example for simplicity, but the point is here you could replace this with your own machine learning model that's maybe iterating over something, and it's at every iteration, it yields the results back. And so we have people that have built very cool real-time dashboards using this. You can do things like build, dashboards that refresh every second. You can do things like build, like streaming chatbots, which we won't get into in this talk, but there's lots of Gradio examples for that. And yeah, so maybe I'll just show this example of a real-time dashboard. Maybe let's see if it'll work here. Yeah, so this is an example of a real-time dashboard here. We can actually it's reading from this Google spreadsheet and kind of showing this as a plot, and it's refreshing every 5 seconds. If we wanted, we could actually edit this spreadsheet, and it'll update the data in real time. But just for the sake of time, we won't go through that. You can do a lot more in Gradio. You can chain events together. You can update the properties of different components. I'll leave this and I'll share. You all have this access to this Colab notebook, so you can run it on your own time and kind of see how different things work. The last thing I do want to mention, because I mentioned this, is you can use things programmatically. So this is the actual last thing, promise. Okay, so we have this dog cat classifier that we mentioned before, and this is running. So again, I can use this programmatically. I can use this via the UI. You can see it's running here, but I can also see here, it says here, if I want to use it via the client, I should just do this. So let me go ahead and do that. So I'm going to copy paste this. I'm going to paste it here. And now I have a Gradio client that's connected to this Gradio application. And now I can do something like .view API, and it'll tell me the data that's expected by the application. So it'll say, hey, you have this one endpoint here called predict, and it takes as parameters an image, and it returns a label. And so now I can actually do something like this. I can actually pass in a prediction here. So I can pass this prediction. It's an image here, and I'm passing it through this API, and you can see I get results back here. Dog with confidence 0.9, cat with confidence 0.1. The predicted label is dog. So you can use any sort of Gradio application in production like this. Okay, so with that, I'll go ahead and end. So if you're interested, again, try out. If you're interested in learning more, including, for example, hosting demos on Hugging Face Spaces, this collab notebook is yours. I'll keep the access open to anyone. So try it out, run through it, and you can kind of do that. If you have questions, you can join our Discord server, or you can ask via Twitter or our Gradio GitHub repo as well. So let me see if I have links to that. Oh yeah, so we just released Gradio 4.0 about a month ago. So it has a lot more flexibility. So you can actually build your own custom components. So you can write a little bit of Python and JavaScript, and you can, and then that can now be a component that can be used in any Gradio application, just like the built-in ones. You get all of the benefits of using Gradio components, including API access, programmatic access as well. We've redesigned our media components from scratch, made sure everything is accessible to screen readers and so on. We use server-side events for everything, and there's a lot more customizability. So yeah, I think with that, I'll go ahead and I will end here. So thank you everyone for attending the talk or listening to the recording afterwards as well. Bookmark the repo. So if you click on gradio.dev, gradio.dev, it'll take you directly to the GitHub repo. And we ask, if you want to stay updated, if you find this useful, just go ahead and star the repo. And also, Twitter is probably the primary way that we communicate. So if you're interested in staying up to date, just follow us on Twitter. The Twitter handle is super simple, just at Gradio. So with that, I'll go ahead and I'll stop. Thank you again. I think we have a couple of minutes, maybe, if anyone has any additional question. Oh, cool. Okay, so we have a lot of questions here. Okay, so we have a question here, Christiana. Okay, so what's happening there is you're probably trying. So Christiana has a question about hosting Gradio application. What you're probably doing is you're actually using the share equals true kind of link. And what that does, it downloads a binary so that we can create this share equals true. So we've made it super flexible now, including the possibility of hosting your own Gradio share server. So kind of reach out to us afterwards, and maybe again on the, you can follow up on the GitHub repo on this issue that you flagged, and I'll share instructions on how to set that up. Basically, it's just some operating systems or some kind of usually Windows that tends to think that that binary is antivirus. There are ways to get around that though. We'll make that easier. Nishan had a question about how does Gradio handle privacy concerns for demos hosting on Spaces. For example, a demo builder publishing to Spaces. I would like to ensure the demo users is handled in an appropriate manner. Okay, yeah, it's a great question. So Spaces by default, they don't have any sort of persistent storage, and so what you can do is there's no persistent storage. So anytime that space gets restarted, all files will get destroyed. So by default, it's actually a relatively private kind of privacy preserving thing to host your Gradio demos on Spaces. If you have more specific concerns, there's like other features that we offer as well. If you're worried about GDPR compliance and things like that, there's something known as the Enterprise Hub, which kind of offers some additional privacy and things like that you can look into. But it kind of depends on what specifically you're looking for. So Angelos, a great question actually here. Bidirectionality of information between plot, image components, and blocks. Yeah. So with image, we actually have this. So we have a select event on image, where if you click on an image in an image component, that data gets sent, including where you've clicked. So then you can kind of start doing interactive things. And in fact, if you guys have heard of Segment Anything from Meta, they built a really cool Gradio demo where wherever you click, that part of the image gets segmented. So that's possible because of the select event listener. We currently don't have that in the plot component, just because the plotting components are relatively, they're like kind of custom, and like they support Plotly, they support different things like that. But Gradio 4.0 comes with the ability to create your own custom components and define your own events as well. And you can use the existing Gradio components as starting points. So one very cool thing you could do is you could actually extend a Gradio component, create your own custom component, and then publish it so that you or anyone else can use it as well. So yeah, thanks, Angelos, for that question. All right. I think that's everything, and that's right on the dot. So thank you so much, everyone, for joining. It's really been a pleasure speaking with you, and great questions.
Thank you again, Abubakar. There's actually one more question, which is there any repos with lots of Gradio examples and use cases?
Yeah, absolutely. So the Gradio repo itself has a lot. So I'm going to go ahead and just share my screen here. So if you could go on the Gradio repo, you'll see here a folder called demo, and it has a ton of Gradio demos for a lot of different use cases. So everything from, I don't know, streaming wave to vex, so streaming audio if you're interested in that, streaming ASR. There were a lot of questions about audio speech recognition and stuff like that, to kind of more basic demos like reversing an audio file, and things like that. I will mention probably the best. So these are fine, but if you want to see like what people are actually building, my recommendation would be to go on Hugging Face Spaces. The cool thing about Hugging Face Spaces is, you have, so this was, for example, a model that was released by Meta. You have real demos that people are building that are very popular, and you can see the source code for any of them. So just click on the Files button. You can see the source code for everything, the full source code. So that's maybe a lot. Let's try it. Let's try this one here. So this is a cool demo that was built automatic hallucination detection. Again, go on the files. You can go on app.py, and you can see here typically the full like Gradio application. So maybe for getting started, I would say use these ones. They're kind of simpler and they're built by the Gradio team. But if you want to see, like, if you're kind of already familiar with the basics of Gradio, you want to see what people are actually building, then you can go on Hugging Face Spaces. And I look forward to your Gradio application on Hugging Face Spaces as well.